Class example 1.42 is a wonderfully challenging question, which is rather conceptual. The reason for this is we're asked to work on the function y equals f of x, but we're only given a domain and range. We're not given an equation in terms of x, and we're not given a graph. However, I bet that you could sketch a graph that satisfied a domain of -4 to infinity and a range of -infinity to 9. Take a moment to do so before proceeding with the question. Now, we're asked to provide a mapping rule for a transform function described by y equals -1/3 f of 2x. And then using this, we will determine the new domain and range. We know that an a value of -1/3 means a reflection in the x-axis and a vertical stretch, or a stretch about the x-axis, by 1/3. A b value of 2, that coefficient in front of the x, represents a horizontal stretch factor, or a stretch about the y-axis, by a factor of 1/2. So we write that all points x, y become 1/2 x and -1/3 y. Let's get back to that sketch of yours. I drew a partial parabola with an endpoint at -4 and 9. In order to visualize this after, I applied the mapping rule to the endpoint. This gave me a new endpoint of -2 and -3. But be careful, while the x value was only stretched, the y value was stretched and reflected. Well, if that point was reflected, so was the entire range, which is to say the entire graph is now going to open up instead of down. This will affect whether our values are minima or maxima when writing the domain and range. So for our domain, the -4 that became the -2 is still the minimum value of the domain. However, the +9 that became a -3 has changed from being the maximum value of the range to being the minimum value of the range. Let's now look at part B, which again has multiple transformations. One of the first things you'll want to do if given a transformed equation is make sure that it is rewritten or properly written in the format that makes most obvious to you what the parameter values are. Here, because it originally said y plus 5 on the left side, the k value had a sign, a positive sign instead of a negative sign, which we're not accustomed to seeing. Also, within the bracket, we saw a -x plus 1. We need to factor that -1 out as a b value in order to make the h value, or horizontal translation value, and direction more explicit. From here, we can write our mapping rule. We see that x has been affected in two ways. There's a reflection in the y-axis and a translation of 1 unit right. Our y value has been affected in two ways, a vertical stretch by a factor of 2 and a translation of 5 units down. Much like the last example, we'll apply this mapping rule to our endpoint of -4 and 9. This time, our new endpoint is at 5 and 13. Much like our last example, our graph has undergone a reflection. However, this time, a horizontal one. That means that the domain will change from having a minimum value to having a maximum value. As we can see, our new domain is from -infinity up to 5, and our new range is from -infinity up to 13.